So now going forward, next experiment is to design RC phase shift oscillator using IC741. Now when this is one of the experiment, how to understand logically and how to present that on answer sheet. So let's analysis this way. To design RC phase shift oscillator is nothing but the output should be through CRO. There should be sustained oscillations continuously being generated. So to perform this task, the components needed is op-amp IC741, and we need dual power supply, that is 12 volts and minus 12 volts, which will be connected across the terminal 7 and 4. Then we need total 3 resistors whose value is 1 kilo ohm and 1 RF, that is feedback resistor, 47 kilo ohm. Then we need capacitance value of 0.01 microfarad, 3 in number. Connecting wires, CRO, breadboard. Now let's understand some logic, how to design it, so which will again help to answer Viva question. Now to generate or to design IC741 as an oscillator, the condition is there should be sustained oscillation. That means there should be continuous sustained oscillations. To do that, the condition is Parkinson's criteria. What does Parkinson's criteria states? To generate sustained oscillation, total phase shift around the loop should be 360 degree and loop gain should be greater or equal to 1. So this is what something theoretical condition says. So one of the Viva questions definitely Parkinson's criteria. Parkinson's criteria says that for the sustained oscillation, the total phase shift around loop has to be 360 degree. Now let's design it. Now to design, we have taken the value of R as 1 kilo ohm and capacitance as 0.01 microfarad, and this is the formula to design the sinusoidal wave whose frequency is 1 by 2 pi RC under the root 6. When this is tabulated using the value resistance as 1 kilo ohm and capacitance as 0.01 microfarad, so the value of frequency obtained is 6.5 kilohertz. So once we design the oscillator with the certain values of R and C, let's analysis main important condition, that is gain should be greater or equal to 29. This is very important condition for sustained oscillation. So in our design, what is the value of R1? 1K. In our design, what is the value of RF? 47K. So the formula for gain is RF by R1, that is 47K divided by 1 kilo ohm is nothing but 47 which is actually greater than 29, so which satisfy the condition, that is gain should be greater or equal to 29. So with this design that we can generate sustained oscillations. This is, it has been designed like this. Now let's see practically how to connect. So as usual, the breadboard will be taken, and pin number 2, it is actually inverting terminal. Pin number 3 is the non-inverting terminal. The non-inverting terminal 3 should be grounded, and pin number 2 should be connected with respect to 1 kilo ohm. At the same time, between pin number 2 and pin number 6, that is output pin, we have feedback resistor 47 kilo ohm, which is actually variable. Suppose if the output generated is not sustained oscillations or oscillations are not generated properly, that time this resistance value can be varied to adjust the value of oscillations. So next, this is RC. Like this, the RC network should be connected such a way that we know that one RC network provides 60 degree phase shift. At the same time, IC741, that is inverting op-amp, also generate the phase shift of 180 degree. From the circuit diagram we can observe we have 3 different RC networks. If one RC can generate 60 degree, then 3 RC will be generating phase shift of 180 degree. Therefore 180 plus 180 total phase shift produced by over this network is 360 degree, which will satisfy Parkinson's criteria. So coming back to the connection, like this RC connection is built and pin number 6 is connected in between pin number 2 feedback resistor. Once this connection is made, this pin number 6 should be connected to CRO. So once again CRO, again it will be having the positive and negative. The positive of this CRO should be connected to 6 and the other one should be connected to the ground. If the connection is proper, how pin number 7 should be connected to plus VCC, pin number 4 should be connected to minus VCC, and RC is connected in this pattern. Pin 3 is grounded. Pin number 6 is connected to the output of, the CRO is connected across the pin number 6. At the same time, one of the end of this capacitor is also been connected to pin number 6. And another end of feedback resistor is been connected to pin number 6. If it is designed properly with the appropriate value of resistance and the capacitor, the output generated will be the continuous oscillated wave, which is sustained oscillation. Now, how to verify our design is correct? As per our design, we should get frequency of 6.5 kilohertz. Whatever the waveform is obtained on CRO can be measured. If along the value which is along x-axis is period, by calculating the period for one full cycle, that is one cycle will start from, so this time period for one cycle is calculated, which is given by period, and the reciprocal of this period will be frequency. So this is how the theoretical design should match with practically obtained waveforms frequency. So this is how to design RC phase shift oscillator and learn with respect to exam perspective.